So everybody listen to the connection of what this unit has been. So this unit so far, we've been looking at polynomials of every degree, right? We've been looking at graphs of polynomials, finding max and mins, increasing intervals and decreasing intervals, right? We've been looking at end behavior and turning points, right? Then one day, remember, we were solving and finding the zeros of a polynomial. Didn't we do that by factoring, by grouping? And then we also factored out a greatest common factor and then factored a quadratic. And then once we have it all factored, can we solve it? Okay, then once again, we were graphing, and then that brings us to today. So what today is going to feel like is a really weird shift of gears. You're going to be like, well, what the heck? So dividing polynomials is kind of random today. Today we're learning how to do that. There is a reason, and I'm going to make that connection today of why we're doing this, because we're going to use it in the next unit to factor polynomials and solve them. Does that make sense? Today you're just learning how, but now then after we test, it'll feel like a random thing, but then we use it to continue to solve polynomials that can't be factored, or that we don't know how to factor. Does that make sense, everybody? Okay, cool. So everybody, I'm trying to start out really basic here to make this connection for when we get to the harder stuff. So everybody watching, it went so well first hour. Okay, when you divide a number such as 18 divided by 6, it equals 3, right? Okay, that's true. Now, didn't that divide evenly? Meaning there was no remainder or no decimal. So if it divides evenly, that means we have a remainder of 0. Now, if you have a remainder of 0, then isn't it true to say if 18 divides by 6 equals 3, and they divide it evenly, then isn't it also true to say, well, then this times this equals this? Isn't that true? Okay, awesome. So we knew for a fact, since it divided evenly, that this was a factor of 18 and 6 was a factor of 18. All good? We're going to now take that into a little bit harder stuff later. Now look right here. When you divide something that doesn't divide evenly, you can still do it, but it's going to have a remainder. So look right here. 9 divides by 2. It doesn't divide evenly, though. 9 divides by 2 and becomes 4, which has a remainder of 1. So why is it a remainder of 1? Because I'm looking, how much does it divide evenly? 4 times. Isn't that 8? So that leaves me with a remainder of 1. Does everybody get that? So now, yeah, but understand, though, because there was a remainder of 1 and it wasn't 0, don't we know for a fact that that times that does not equal 9? Okay, good. But we can still divide it, and yes, technically we can write it like this. So look, 9 divided by 2 equals 4 with a remainder of 1. So it's also true to say that this times this plus the remainder equals 9. Does everybody see? So we just add the remainder. That's going to now apply to polynomials as well. So everybody, starting out with number 1. I hope you listened and have paper out. It's going to take a lot of paper. So what we're doing is I'm teaching you how to divide a polynomial using long division. Now, long division is kind of long, but the thing is long division always works. You can always use long division to divide polynomials. Did you hear that? So no matter what, you can use long division to divide polynomials. Okay, here we go. So I'm going to show you how to do it. You just got to follow me through the steps, kind of memorize the steps. So what we're doing is we're taking this polynomial divided by this polynomial. So what we're dividing by goes on the outside of the house. So you're going to set up x plus 3, and you're going to draw in a little house here. What polynomial is being divided, that's what goes under the house. So under here is x squared minus 13x minus 48. I'm going to let you all get caught up there. All right, this is always how we set up long division problems. Now, fun fact for you, with long division, all you have to focus on is dividing the leading terms. So everybody, what I mean by that is this is a leading term, this is a leading term. You only divide the leading terms. So now you have to make your work nice and pretty, and we go about in a roundabout process, so we're going to start over here. I make little bulletin points to show my work. So I'm doing a bulletin point, I'm going to show my work right here. Here we go. So you divide your leading terms. So x squared is being divided by x. What do we get when we divide those? X. That's part of your solution. So your solutions we write on top of the house here. Now I always line things up just to make my work nice and pretty. So if this is an x, I'm going to line it up with my x's here. So x is part of my answer. That's on top. Is everybody good? Okay. So now what we're going to do, so I divided this and put it on top. That's part of my answer. Now what we're going to do is we're going to take x and we're going to multiply it back down in here and here. So here we go. X times x is x squared. And that's coming back under my house. Let's line it up. So x squared, you just said. Very good. Now x times positive 3 is positive 3x. I'm going to let everybody get caught up. Okay, now understand what we are trying to do now is we want these x squareds to cancel out. If we add straight down, isn't that going to become 2x squared? That's a problem. We need them to cancel out. So don't we need this one to be negative? Now if I just change that to negative though, we've now changed the problem. So if we change this to negative, that's fine, but we have to change the sign on this one too, because then we've done it evenly. Does that make sense? So why did we do that? Because we need these to subtract out here. So now we're going to add straight down. So we add straight down and write what's left over in our house. X squared minus x squared is gone, which is what we wanted. Negative 13x plus negative 3x is negative 16x. And you got to be so careful because a lot of people mess up right here where they switch the negatives or adding straight down. And if you get this wrong, the rest of it's wrong. Okay, now don't we still have negative 48? Okay, perfect. And now look, we're just literally starting the process over again. So now we were going in a roundabout circle here. So now I go off to the side and say, I only divide out my leading terms. So negative 16x divided by leading term x. What do I get? Good, negative 16. That's part of my answer. So that goes on top. So minus 16. And now once again, it's just a roundabout process. Now we're going to take negative 16 and we're going to multiply it back down. Negative 16 times x, negative 16x, negative 16 times positive 3. Negative 48. Now here's where people forget. We need these 16x's to cancel out. So we need to change the sign on this second one. If you change this sign, though, you've got to change this sign. Okay, perfect. And now we can add straight down. 0, and then doesn't that happen to be 0? Okay, look. All right, let's look now. Can we take 0 divided by x? No, so that's why we know how we know we're done. So that's our remainder. Our remainder was 0. Now, does everybody understand that that means it divided evenly? So isn't it true? So this is our answer. Everybody listen to what the answer is. We took this polynomial, divided by this polynomial, and we got this. So everybody see, that's my answer. All good. We divided a polynomial by a polynomial, and we got that polynomial. No, x minus 16 is our answer. Okay. Now, but this is what I want you to make a connection of. I'm done. X minus 16 is my answer. But I need to make a few more connections here. Now, since we know our remainder is 0, it divided evenly, and then we got this is our answer. Isn't it true now to say that this polynomial right here was equal to that times that? Just like we talked about. So it's also true, what we also know is that since it divided evenly, that it's true to say x plus 3 times x minus 16 equals that, right? All good. Now look how useful that is. Well, now can't I solve if I ask you to? We have it factored, can't we solve it? So because our remainder is 0, don't we know that negative 3 is a solution? Does everybody see? If that's a factor, what's a solution, people? Negative 3. Are we good? I can't tell. Yeah. And then what else would be a solution? 16. Very good. Awesome. So that's how we end up using this later on. To see if I said to you, is negative 3 a solution? You could divide it through and see if it comes out a remainder of 0. And if it does, you'd say yes. Does that make sense? So that's how we'll use it in the future. Okay, cool. Let's do another one. Let's do number 4. Here we go. So we're dividing by long division. So we would set up our x plus 2 on the outside of our little house. Draw in your house. So 3x cubed minus x squared minus 7x plus 6. And with long division always works to divide any two polynomials, and you divide the leading terms. I'm going to go off and do my little bulletin point. 3x cubed divided by x is, okay, 3x squared. That's going to be part of my answer then. That goes on top. I'm going to line it up with my x squared just to make my work nice and pretty. Now we're just going about a roundabout circle here. So now we're going to multiply that back down in. 3x squared times x is 3x cubed. 3x squared times positive 2 plus 6x squared. Very good. Now remember, we need these two cancel out. To do that, we've got to change the sign here and here. And now we're going to add straight down. X squared times 3x squared times 2. Yeah, good question. So now we add straight down. Gone. Careful here, people mess it up a lot of times. Negative 7x squared minus 6x squared. Negative 7x squared. And then we still have minus 7x. And we still have plus 6. And now that's the new thing under my house, and we just start the process over. I go off to the side. Do a little bulletin point, dividing the leading terms. Negative 7x squared divided by leading term x is negative 7x, right? Yeah. That's part of my answer then, negative 7x. Okay, next step, keep going around the roundabout circle. So careful right here, negative 7x times positive x is, you're right, negative 7x squared. Negative 7x times positive 2 is, yep, negative 14x. We want them to cancel out, so we need to change the sign. So don't I need to change the sign here? Now add straight down. Gone. Plus 7x, isn't it? Yep, plus 6. And now that's the new thing under my house. Starting over again. The roundabout circle. So I go off to the side, dividing the leading terms. 7x. Positive 7x, so 7x divided by x is positive 7. So we're going to have plus 7. And now multiplying that back down. Positive 7 times x. Positive 7 times positive 2. Positive 14. Change the sign. Change the sign. Add straight down. Gonzo and negative 8. Now look, negative 8 divided by x can't do it. That must be my remainder. So everybody, I'm going to ask you a question. Okay, well, we're not done yet, but I'm going to ask you a question, though, first, before we're done. Is x plus 2 a factor of this polynomial? No. How do you know that? The remainder is not 0, so it didn't divide evenly. Does that make sense, everybody? So I'm going to ask you another question. Is negative 2 a solution of this polynomial? No, if this isn't a factor, then negative 2 is not a solution. Do you all understand? That's how we use this in the future. So making that connection now is going to make it really a lot easier. Okay, cool. So this is how we write it. We still have to factor in our remainder. So how did we write it before? Didn't we add our remainder? Yeah. So we have to write minus, since it's minus 8, so we'd say minus 8 when we divide it by x plus 2. That's how they write it. So minus 8 when we divide it by x plus 2. Yep, right there's my answer. That's just how they write the remainder. It didn't divide evenly. We can still divide them. But now we know a lot about this polynomial. We know once again that x plus 2 is not a factor. And if that's not a factor, then negative 2 is not a solution of that. That's not what we're doing this time. We're just dividing. But I'm trying to make these connections so that it makes sense. Yes. Yeah, so if it was positive 8, we would have just said plus 8 over x plus 2. Yes. No, it's on top of it. Okay. Yeah. Okay, let's do number 30, everybody. Here we go. This will be the last one, then I'm going to let you go for the ones on your homework. So let's do one more with long division. Here we go. So we would set up 3x plus 4. Oh, but I want to say one thing here. I want you to notice something. I should have said this in the beginning. Okay, everybody watch, because this is really going to help when we do some other things. Didn't I start out saying divide this polynomial by this polynomial? And didn't I take something degree 2 divided by degree 1? What's degree 2 divided by degree 1 going to give you an answer of degree what? 1. Does everybody see how my answer came out 1 less than what we divided it by for this one? Okay, let's look at this one. We took degree 3 divided by degree 1. What should my answer be? Degree 2, and it did. Does that make sense? Okay, cool. So look, I'm just asking you for fun. Degree 3 divided by degree 1, what answer is it going to be? A quadratic. Good, a degree 2. Here we go. Let's do it. Go to your little house. Now on this one, let's go teeny bit faster. So once again, with long division, it always works. You can always divide it with any type of polynomial. So look, even if this was, look, let me show you. Even if this was 3x squared plus 4, we would still have 3x squared plus 4, and you'd do the same thing. You just divide your leading terms. Does that make sense, everyone? Okay, cool. Just making sure that you understand it doesn't always have to be 1 for long division. Okay, here we go. Off on the side. Leading term by leading term. 6x cubed divided by 3x. Good, 2x squared. That's on top. We're going in our roundabout process. Multiply that back down. 2x squared times positive 3x. Positive 6x cubed. Positive 2x squared times positive 4. Positive 8x squared. Now once again, we need these to cancel out, so we need to change the sign. Add straight down. Won't this be minus 6x squared? And then we still have minus 11x plus 12. And now our roundabout process starts over again. So we go off on the side, starting over. Negative 6x squared divided by leading term 3x. Feel good? So we get what? All right, that goes on top. Negative 2x. And then we're multiplying that back down in. Negative 2x times 3x is negative. Perfect. Negative 2x times positive 4. You're right. Change the sign, right? That's the most forgotten thing. And then we add straight down. Gonzo.
Not so gonzo.
Not so gonzo, which is negative 3x plus 12, right? Starting over again. Negative 3x divided by 3x is negative 1. So negative 1's back up here. Roundabout process. Here we go. Negative 1 times positive 3x. You're right, we're almost done. Negative 1 times positive 4. Now what do I have to do next? Change the signs, add straight down. We get 16. 16 does not divide by 3x, so that must be my remainder. So wouldn't we say, okay, that's my answer, but then we have a remainder of positive 16, don't we? So plus 16, when we divide it by, let me erase this. Okay, now I can write it better. So it's plus 16 when we divide it by 3x plus 4. There's my answer. I'm going to ask you, this is what's the important question though. So is 3x plus 4 a factor of that polynomial? No. So my question for you is, watch. Is negative 4/3 the solution of this polynomial? No. If that's not a factor, then that's not a solution. Do we understand what's going on here? I can't tell. First hour was a lot more with it. If that's not a factor, then that's not a solution. Well, there's solutions, it's just not negative 4/3. Does that make sense? Okay, perfect. Okay, awesome. Are you guys feel comfortable? Okay, now look at this one. Is it any different? Doesn't that mean divide? Same thing. So when you just set up n plus 3 on the outside of your house and go through the process. Okay, cool. What I want you to do is do 1 through 6 on the front and 1 through 6 on the second page. Ready, go. Long division. So what we're learning is another method to divide, which is way quicker than long division. But here's the catch. Just like with quick factoring, if you use this quick way when you can't, you'll get the wrong answer. So everybody watch so you know when you can use synthetic and when you can't. So synthetic division is a quick way of dividing. But you can only use synthetic division if you are dividing by a linear factor with a leading coefficient of 1. So everybody looking so you know the criteria. Very good. I'm saying take this polynomial divided by this polynomial. We can only use synthetic division if what you're dividing by is a linear factor, so degree 1, and a leading coefficient of 1. Does everybody hear that? If it is, we can use this quick method. If not, you have to do long division. Otherwise, it will give you the wrong polynomial. Does that make sense? Yep, so like for example, if this was squared, we would have to use long division. Does everybody understand? Okay, cool. Now, one more thing. So let's go ahead and do this. So this is how you set up synthetic division. Now, interestingly enough, unlike long division, we don't actually use the x minus 5. Instead, we use the solution. So instead of using the factor and actually doing x minus 5 divided by this, we're going to use the actual solution. So set it equal to 0 and solve. Yep. So x equals 5. So we're using positive 5. So everybody, you're drawing this in on your work. Now you're going to draw on a 5, and then you're going to draw a box, leaving yourself plenty and plenty of room in here. You see how I left myself plenty of room? Okay. Now next thing, with synthetic division, it's different than long division. You're not going to put in your x's. All you're going to put in are the coefficients in front of x. So isn't this positive 1? Then this is negative 8. Coefficient means number in front of the variable, positive 17, and negative 10. Yeah, that's a coefficient, right? Technically x to the 0, right? Okay, so we're putting in and that's called a constant coefficient. Okay, so these are the coefficients. Now, here's one more thing you have to remember. With synthetic division, this is not true for long division, but with synthetic division, if you're missing something, so if we start with degree 3, and let's pretend we were missing this, and we had x cubed plus 17x minus 10. Do you see how between degree 3 and degree 1, we should have an x squared? If you were missing that, you have to put in a 0 where that would have been. Because there's technically a 0x squared if there's nothing there. Does that make sense? Okay, but everything's good. So this is how synthetic division works. We always, every time we add straight down, multiply up. So watch what I mean. 1 plus nothing is what? 1. Now we add straight down and then we always multiply back up here. 1 times 5 is 5. So I place that under this negative 8. So every time we add straight down, negative 8 plus 5, negative 3. And now we always multiply back up. So negative 3 times 5 is negative 15. So we always add straight down, multiply up. Add straight down, multiply up. Okay, add straight down. 2. 2 times 5 is 10. We add straight down and get 0. Now everybody, I want you to understand something. We started with something cubic divided by something linear. What degree will my new polynomial be? 2. So this is x squared, x, constant, remainder. You see how I just counted down? Yep, so our new polynomial is 1x squared minus 3x plus 2, and our remainder 0. Way quicker than long division, wasn't it? So those were just your coefficients. Look, everybody good? Now I'm going to ask you a question because this is what's important. Now, since my remainder is 0, isn't it true to say that x equals 5 is a solution of the original polynomial? Yes, we know 5 is a solution of this. Now, don't we also know that this cubic factored to be this times that. Now look at that. I have it all factored out. Instead of having a cubic, I have a quadratic and a linear. But they're equal, just one's factored, one's not. Does that make sense? That wasn't my answer is this, because of the instructions. It said divide. But if I said to you, write this in factored form, you would have done that and that. Does that make sense, everyone? Yep. Right. That's what we end up using it for. Yes.
So this thing like divide, that would be the answer, but if that's solved, we'd have to like...
Yep, we'd factor it by this method, right? And then couldn't we see if this factored more? And then we could solve it. But right now I'm just asking you to divide it, okay? Yes. And, okay, let's do another one. Number 12, here we go. So let's set up, remember with synthetic division, you use the solution. So wouldn't we subtract 2? X equals -2. So we set up our -2 on the outside of our little box. And then we put in our coefficients, the number in front of the variables, making sure you're not missing anything. Degree 3, degree 2, degree 1, and a constant. We're good. So we put in our 1, our +5, our -1, and our -9. And remember, we always add straight down and then multiply up. So 1 plus nothing is 1. 1 times -2 is 1 times -2. Yep, and then we add straight down. 3, right? We multiply up 3 times -2. And then we add straight down. Yep, -7 times -2. And then we add straight down. Okay, perfect. Now, once again, you took degree 3 divided by degree 1, giving me degree. So x squared, x, constant, remainder. So our new polynomial is x squared plus 3x minus 7. Our remainder is 5. We'd say plus 5 when we divided by x plus 2. There's my answer. Way quicker than long division, wasn't it? Yes, now I'm going to ask you a question. Is -2 a solution of that polynomial? No. Is x plus 2 a factor of this polynomial? No. Okay, good. You guys are getting where we're going to use this. Right. Because when you took a cubic divided by a linear, it gives you a quadratic. We're dividing it, right? So it's going to become one smaller. Okay, 31. There's a reason I'm doing 31 with you. Everybody go to 31. There's a reason. Now, I'm telling you, you can divide this one using log or synthetic division. So which one would you choose? Can we use synthetic? Yeah, 1 and 1. Now, everybody notice, it doesn't have to be 1 and 1 here. You all understand that. This could be a 2, and we can still use synthetic division. It's just what you're dividing by has to be 1 and 1. Okay, cool. Wouldn't I use +1, everybody? 1, draw in your little box. Now, careful, because look, degree 4, degree 3, what am I missing? So 0x squared's tucked in there. Here we go. Put in our coefficients. 1, +2, 0, then 1, right? Then -3. Everybody see how if I would have missed a 0, it would be wrong. Because there's no x squared there. We have to have a coefficient for each place. So since there's not an x squared, we have to put in a 0. Just for synthetic division though. Long division, not necessary. Here we go. We add straight down. 1 plus nothing's 1. We multiply up. 1 times 1 is 1. We add straight down and get 3 times 1 is add straight down. 3 times 1 is add straight down, we get 4 times 1 is add straight down, we get 1. Now once again, we took degree 4 divided by degree 1, degree 3, right? So we would say 1x cubed plus 3x squared plus 3x plus 4, then plus 1 when we divided by x minus 1. So much quicker. We love synthetic division. So 1's not a solution of that polynomial, and x minus 1 is not a factor. Okay, good. Okay, go to number 34. Let's do one more together and let's go quick. I'm going to use synthetic division. How about you? So we're going to use positive 2. Now watch. The reason I'm doing this one is because what am I missing? X cubed. And what else am I missing? 0x. So we're going to have a 1, a 0, a negative 3, a 0, and a negative 10. Does everybody see why? Okay, you got to remember that because it's not going to be said to you. You're going to have to just remember that. Okay, we add straight down. Multiply out, add straight down, right? 2 times 2 is 4. Add straight down, we get 1. 1 times 2 is 2. We add straight down and get 2. 2 times 2 is 4. We add straight down and get negative 6. We took degree 4 divided by degree 1, giving me degree x cubed, x squared, x constant remainder. Okay, awesome. Here we go. So when it divided, it was 1x cubed plus 2x squared plus x plus 2 minus 6 when we divided by x minus 2. And now we just know so much about this because we know that 2 is not a solution of that and x minus 2 is not a factor. Didn't divide evenly. Okay, are you guys good to go? Once again, with synthetic division, if you're missing something like a coefficient, like you see how I went from x fourths and it jumped to x squared? I'm missing an x cubed then. So there's technically 0x cubed. You have to have a placeholder for each piece. 1. Constant. Even constant. Yep. Okay, awesome. Look at the back. So we're not going to go through this one because I think you can do it by yourself. But isn't it the same thing? How would I set up my synthetic division? Negative 8, wouldn't I? Negative 8, right? You mess up and put 8, you're going to get it wrong. All good? And then you'd put in 1, 15, 55, negative 14, negative 48, and you just go like a maniac. Okay. Right, ready to go. Stick with the ones I have on the board, please. Do 11 through 20 on the front, and then 7 through 12 on the second page. The second page. Ready, go to 21. Now let's read the directions, because this is where people miss on the test. They don't read the directions, and they don't know what they're being asked. So it says, use synthetic division and the given factor. Are you listening? Okay, once again, use synthetic division and the given factor to completely factor each polynomial. So think about it. They're telling us right now that this is a factor, right? Isn't that what the direction says? Yeah. So don't we know if we take a cubic divided by something linear, we're going to have a quadratic. And don't we know, since we're told it's a factor, that it's going to have a remainder of 0. Right? Okay, so let's divide this. Let's do it synthetic division style. So we have negative 5, because we're using the solution. 1, 3, negative 13, negative 15. Here we go. 1 times negative 5, add straight down. Add straight down. Add straight down. 0, which makes sense, because they told us that x plus 5 would be a factor. Does that make sense, everybody? So now it says, use this to factor this completely. So first of all, don't we know now that this is x squared minus 2x minus 3? And don't we know that this times this equals this? So let's write that. This times this equals our original polynomial. Now we would check though, we don't check, it says factor it completely. Let's see if it is factored completely. So let's look here at this quadratic. Oh, we better check. Can't we factor quadratics sometimes? What multiplies to be a times c adds up to be b? Okay. What multiplies to be a times c and adds up to be b? Negative 3 times 1. Can I quick factor the quadratic? So this factors to be x plus 1, doesn't it? And x minus 3. And then don't we not forget about this? And now isn't it factored down to 3 linear factors? So I know I've factored it completely, right? Right. That would be my answer. That's factored completely. Now why is this useful for us in the future? This is how we'll use this in the future. I'm going to say solve the polynomial. So then you could factor it using this method, and then you can now say my solutions are negative 1, 3, and does everybody see how this would be useful? Well, the instructions said factor it, so we'd stop here. All good? You have a question? Yeah. Okay, let's do this one. Determine whether each binomial is a factor. So won't we just divide each of these and see if the remainder is 0? Can you answer these things that are a little different? Okay. So it says determine whether this, and this are factors of this. So let's go ahead and divide this using synthetic division. And if the remainder comes out 0, won't we say yes? Let's all go through this one really quick. So we drop this down. 1 times negative 4, add straight down. 4, add straight down. 24, add straight down. 0. So isn't my answer yes for this one? If the remainder is 0, then it divided evenly. Therefore, that's a factor. All good. Do you see how this works? So if my remainder would have come out something that wasn't 0, I'd say that's not a factor. Pretty good? Yep, on those ones, yes. What I want you to do is do another one in the section 21 to 24. The one where it says factor this completely. Ready, go. So it says, let's read the directions. It's nothing new, but you've got to know what it's asking you. It says divide using any method. State if the given binomial is a factor of the, this is almost exactly how it's worded on the test. So let's read this one. State if the given binomial is a factor of the given polynomial. And if it is, write the polynomial as the product of 2 factors. So let's go through this. So let's see if it is a factor. Isn't that what it's asking us? So wouldn't we just see if the remainder is 0? So let's do negative 2. Let's do synthetic. 1, 6, 3 add negative 10. Add straight down. Negative 2, add straight down, right? Negative 5, isn't it? And then negative 5 times negative 2 is 10. Add straight down, we get 0. So we would say, yes, it was, because our remainder is 0. But now we have to answer it. It says, if it is, write the polynomial as a product of 2 factors. Meaning, we know for a fact that this became, so that is what? Well, what? We took a degree 3 divided by degree 1, didn't we? Yep, so x squared plus 4x minus 5. And then it says write it as the product of 2 factors. So when we have our x plus 2. Now look, that is the product of 1, 2 factors. So do you see how they just stopped here? They didn't continue to see if it continued to factor. However, I would not mark it wrong on a test if this quadratic did factor if you kept going, because then you're just being way on top of it. Does that make sense? But by the wording, doesn't it say write the product as 2 factors? Done. Not as factors completely. All good? Yes. So you would continue to factor the quadratic. Okay, cool. Okay, this is what I'm going to have you do as homework. So you're going to be able to put, okay, these are the ones you're doing. So on the front page, you need to be doing for homework, do 1 through 25 on the front page. We are not doing, do not, so make yourself a little note, do not do 26 through 41. Then you need to do the entire back last page. I'll call it the last page. Do the entire last page all. Do the last page, what the? I can't speak and right. So everybody, yes. Even though we did some, I was doing those for, because those are the advanced ones, so we did those together. And then 26 through 29. Yes. Okay, so the only ones you're crossing out, guys, are 26 through 41. No, it's due on the day of the test, but I wouldn't wait because the real test review will be given to you next time. That's a required assignment, yes.